Раз, два, раз, раз.
Nothing?
Hello, guys. Let me introduce Fabio Alessandro Locati, and he will be giving a talk about automating your infrastructure with Ansible.
Hello. So, I'm Fabio Locati, and I work in Red Hat as a consultant, and I mainly do consultancy on Ansible. So, hopefully my clicker does work. Yes. So let's start with a very quick introduction. So I started to work in IT in 2004. That is 13 years ago now. And since 2013, I started to use Ansible. Why I'm saying this? Because what we have shown in the last 15 years is that actually the IT needs have changed a lot. And I think that this is critical to understand why we are using Ansible and why we want to use Ansible and maybe not other options. So surely we have reasons for having a configuration management system. So the first one is auditability. If you have a configuration management system, obviously you can actually look at any given time what is your configuration on the server. This is obviously assuming the fact that you have not manually changed the configuration on the specific server. But if you have not done that, actually you have the whole recipe to create that server, and therefore you can say, you know, that servers work like that because this is how we built it. Then we have another problem with that is job hopping. So people tend to change job more quickly. 20 years ago, people usually tend to stay longer on the same job. Now it's more rare. So you have a big problem of lost knowledge when someone leaves the team. So if you have something like a configuration management system, you actually have the full documentation of your infrastructure as code. And this also has other advantages, as we will see. Another advantage is speed. 10 years ago, it was pretty common to actually design a new infrastructure, a new service, and then buy new boxes from some vendor, Dell or HP or whatever, and then wait a couple of weeks that they can be delivered, and then cable them, so another weeks, and then install all the software, and then do all the other stuff. So it was like a 1 month process, maybe more. And then it arrived VMs, which is far quicker. You want a new machine, you just provision it. And then we are now on the cloud age, where we have cloud loads that change the number of machines they are running on based on the load and other factors. So they actually change the number of nodes that you are managing in a matter of minutes or hours. So here we arrive to the scalability problem. How can you actually scale to that level? How can you configure 100 machines in 10 minutes? Because if you have a very small website that at a certain point get referenced in some big, newspaper or news website, obviously you want to scale very quickly to obviously meet the demand, so you have a scalability problem. And also in the cloud, you scale horizontally. So before, if you wanted to scale, you just add more RAM, more CPU, and that was it. Today you add more boxes, so you have more boxes actually to manage. So this one also becomes a big problem that is also known as the number of hosts that a manager can manage, which is a few years back when you had like 5 mainframes and your whole business were running on that. You were actually managing 5 hosts. Today, you are managing thousands of hosts, but you cannot have the same ratio of technical people to hosts. And today, there is a quality of service which is expected. 10 years ago, 15 years ago, well, it was 10 years ago when I was 18, actually, I had my first credit card. And my credit card company did not allow me to do any transactions from midnight to 6 o'clock in the morning because, the system were doing stuff. And today, that kind of, downtime is not possible because business would not allow it. So automation is clearly the answer. So automation has infrastructure as code or data, as we will see. This means that it's very easy to read for humans and to read for machines. And also, the big advantage of this is that the code itself is the documentation of the infrastructure. We always had documentation for the infrastructure we did, obviously, because you want to have documentation of that. The big problem is that very often those documentation were like 5, 10 years out of date because no one bothered to actually update it when they changed the infrastructure. So that was not very useful. If you are using the paradigm of infrastructure as code, since your infrastructure is the result of your code running, that means that that code is exactly what your infrastructure is. This obviously simplifies the auditability problem a lot. And in theory, you could achieve a point where you have no users, no real people actually accessing those machines as root. And this would grant you, that no one has connected to the machine and effectively changed the configuration in it. And also, this grants you that everything that happens on those machines is actually logged. Because we have a big problem that if you have a single user on a system that is root, he will actually be able to evade any kind of logging or it will be very hard to actually have some kind of logging that he cannot evade. But if we don't have any root users, well, that problem goes away. And obviously, it's pretty easy to scale out. You just reapply the same code to every new machine you create, and you have more machines that are equals to the one you already have in the clusters. So there are a few concepts that I want to go through before going forward. The first one is the idea of agent. Mainly, we can divide the configuration management system in 2 big families, the with agent and the without agent ones. So the agentful, like Puppet, for instance, have this daemon that is running on every single box. And this daemon simply checks in every n time and asks to the master, do you have anything new for me? And if yes, they apply it. If not, they wait for the next check-in. The agentless systems usually have the master calling all the systems and saying, you have those updates to do. Now, both approaches have advantages and disadvantages. The big advantage of an agent is the high performance during the execution because all the execution is actually done locally. If you have like a DNF install or a YAM install, if in a case of agentful state, you actually have the agent asking to the mother, to the master node, what do I have to do? And the master node says, you have to install Apache. And locally, the agent will install Apache. While obviously in the agentless model, we don't have this, but we have the master node that will contact the SSH usually, all the nodes, and says, you need to install Apache. And there is an SSH connection that stays alive for the whole length of the process. So obviously, we have a speed advantage with agents. Second advantage is that the connection between all your hosts and your master host is client managed. So that is pretty standard. You know, HTTP works in the same way. You have the server, and then all clients connect to the server, which is, you know, normal, I would say, in the IT industry. So it's a very well-known concept. And if you go to, you know, a network administrator or a security administrator and say, I want to do this kind of thing, he knows exactly what you're talking about. But this model also has some disadvantages. The first one is that obviously, due to what we have just said, you need to put your master node in the least secure part of your network, or you put holes in your firewalls, which is probably worse. But I mean, that node actually contains the whole configuration of your whole environment, and therefore you don't want it to be in your least secure part of the network. You would actually want it in the most secure part of the network. And also, resources are used even if there is no updating to be done. So if you think about this, on average, you don't roll out one update every 30 minutes on your infrastructure, while Puppet, for instance, by default, checks in every 30 minutes. And this means that, obviously, every 30 minutes, if you have 1,000 hosts, you will have 1,000 requests to the master host. You know, is there anything new or not? And the majority of times, that answer will be no. So you're wasting resources there. And we have said that in the agentful case, we have the master in the least secure network segment. In the agentless case, we obviously have it in the most secure segment, because the master will need to initiate the connections. So the connection that will be needed, you know, will be from the master to the saves. So the third big disadvantage, I think, that an agentful system has is that actually, if you have 1,000 nodes, you have 1,000 agents. If you have 1,000 agents, that means that you have 1,000 daemons to take care of. That means that, you know, all those daemons can crash, and therefore your machine does not get any updates or that kind of stuff, because the daemons is not up anymore. And also, we have a chicken and egg problem, because since someone or somewhat that daemon has to land on that machine, or you install it manually, or you bake it into the image, or, you know, you need to do something weird. Actually, I have seen a code written by a consultant, an ANSIBLE code to deploy Puppet agents, which is, I think, weird. But still, people do it, because if you want to have 1,000 of Puppet agents deployed, and you don't have an automation system, how can you do it? Surely not with Puppet, but for instance, with Ansible you can. So the other principle I want to talk with you about is idempotence. This is very important in automation. Now, you can do automation without idempotence, but it will be a mess. Now, the idea of idempotence is that an operation, after you have done it, there are some operations, that after you have done it one time, if you redo them a second time, they will actually have no effect. So, for instance, if we have a number, we multiply by 1, it will have no effect, because, you know, that's how maths work. And we can do here the same thing. So the idea is that we have some operations that can be actually idempotent. For instance, if you think about installing a software, as I install a software that is not idempotent. But if I try to achieve a state, which is I want that software to be installed, that is actually idempotent, because the first time you will need to install it. But from the second time, you will actually not do anything, because software is already there. So Ansible push the idea of infrastructure as code a little bit further, because in fact we speak about infrastructure as data more than as code, because it does not really look like code. It's actually YAML file. So one of the big advantages is that it's really easy to write. YAML code is like JSON, but easier because you don't have all the parentheses to match. It's even easier to read because it's not code. If we have like Puppet, where the majority of infrastructure is actually Ruby code, that is kind of not that easy if you don't know Ruby. If you know Ruby, everything is fine. But I mean, here we are speaking about a level of simplicity where even a non-technical person, like an external auditor, can actually understand somehow what's happening there. And only the fact that we don't want to, version everything. I have seen in the beginning of my career someone that actually put the whole Etsy folder in SVN. I mean, that was a great idea because you have everything versioned, but that was also a problem because when you do an update, you may have some changes there, but they are just trivial for you. And also the fact that Etsy is a pretty big folder, and like 99.9% of that stuff is completely useless for you. That makes that system not perfect. So this is an example of a YAML code, a working one. So this one is a playbook, an Ansible playbook. So we declare which host we want to hit with this playbook. Become true means that we want to escalate to to root as sudo. Tasks are the actions we are going to perform. So the first one has a name, so that it makes it even easier to read. That ensures that MySQL is installed. So we use the module yum, name MySQL, that's the name of the thing that we want to deal with, state present. So that's pretty straightforward. And again, if we want the user Tom to be present, same thing, ensure Tom is present. User, this is the module we are going to use now, name Tom, state present. So as you can see, this is pretty straightforward. I would say even a non-technical person with a 5 minutes training can actually understand what is going on. Probably will not be able to write YAML code or Ansible code, but it will be able to understand it. So basically, Ansible is written in Python, first of all, which can be an advantage or disadvantage. This is kind of a big advantage because it's flexible. It's not Bash. And Python runs pretty much everywhere. We have Python running on Windows now. We have Python on pretty much all Linux systems. If you consider that, for instance, Anaconda is written in Python, the Fedora Red Hat installer. So that is like, you have Python there. And all the other Linux systems have Python, and a lot of other non-Linux Unix systems also have Python. So that's good. It mainly works in push mode, so agentless. It can also work in pull mode. There is Ansible pull, which is a weird thing, but it's not agentful, is even there, but it's different. But I would say 99-point-something% of the usage of Ansible is actually in push mode. So big advantages is infrastructure as data. As we have seen, YAML is very straightforward. And therefore, the learning curve is very gentle. It's very easy to learn to write YAML code. You can actually, I was speaking with a customer a few weeks ago, and he was like, oh yeah, I have started yesterday to look at this YAML Ansible thing, and in less than 1 hour, I was actually running my first Ansible playbook that was actually doing something useful. So that's, I think, a very good one. Very easy to set up. You just install on the master Ansible, write your playbook, and run it. You don't have to do anything weird. And also, it's, I would say, a balance tool. It's like, it's not perfect probably in all scenarios, but it's very, very good in all scenarios, and in many scenarios is, I think, very close to be perfect. So it's like from provisioning, like Terraform kind of provisioning, to stuff like Chef kind of, multi-thing. So it's like, very balanced. So some disadvantages, no tool is perfect. The first one is that we don't have perfect introspection tools yet. There is a lot of effort here, so hopefully in a few months we will have better introspection tools. And second one is the fact that the community is young. And I think this is a very big advantage, because if they have been able to actually create this in a few years, what will happen in 5 years' time, or that kind of thing. But yeah, it's kind of a problem, because you find way more Puppet documentation than Ansible documentation, simply because Puppet has been around for more than double the time than Ansible has. So I was speaking with a person a few days ago, and he was like, yeah, but if I want to start to use Ansible, or if I want to use Ansible in my infrastructure, what are the steps? What people usually do. So first one is usually write few actions in Ansible playbooks. That is like, you need to create a user, and instead of going around and create a user, you just create an Ansible thing, a script, a very small script that actually creates a user for you. And then maybe you go a little bit further, and then you create a set of basic things like NTP configuration for your environment, basic SSSD kind of configuration, or like, basic things that you usually configure on a new machine. And then many people start to roll out one machine completely based on Ansible, or one kind of machine. Usually it's the easiest one. And then, you move forward with migrating all machines to Ansible. Obviously, you can stop wherever you want, or you can do, whatever order you want, but that is how usually people do. And I would say, as far as I have seen, the majority of people comes all the way down because they like Ansible a lot in the first few steps, so they go ahead. So I think that's very good. So yeah, let's go with the demo. Hopefully it will work. So this is my Cloudflare account. I have one domain set up, and this one is my DigitalOcean account. Now, we are going to start from here. As you can see, there are 3 boxes here, which none of them are .file.bits. And here we have a file.bits domain. So what we are going to do is actually I will run the code and then explain it, mainly because it's a little bit long, the first execution, since we have to provision a couple of machines. So what we are going to do while it works, let's see, because sadly I cannot see the same thing that you see. So, okay. So this one is my Ansible project we are seeing. I hope it's big enough. Okay, good. So we have few files here. So mainly we have some folders. We have an Ansible CFG file, which is configuration for Ansible. You can have it, not have it, if the configuration by default is fine for you. Then you have an inventory folder, in my case, could be a file or whatever, where is the place where you put inside it, your host and the other things. And then you have your master.yaml file, which is usually your entry point to deploy your whole infrastructure. Then some playbooks, which sometimes can be thought as manual actions, if that is a thing that you want to do. Other times can be, the deployment of a single kind of host or a single host. It depends. I have, for instance, a provision for DigitalOcean and CloudForm, a tier down for DigitalOcean and CloudForm, and a first run script, because on the first run I want to clean some configuration that I don't agree with that are in the default one. For instance, by default, it arrives with the root account. I don't really want a root account. And then, groups, I will deploy 2 web server and 1 DB server. So we have 1 YAML file for DB group and 1 for web. And then we have, a README, guess what? And then roles. Roles are like playbooks, but a little bit, they allow you to split things. And usually the big difference between roles and playbooks is that roles, you really want them to be idempotent. Playbooks can be idempotent, can be not idempotent. That's really up to you. But roles, if they are not idempotent, that will make problems for you. I have 3 roles. One is common, that will be deployed on all machines. One is DB, which is only for databases, and one is web, which is only for web hosts. And then I have a vault.yaml file, which is encrypted and contains my keys for DigitalOcean and Cloudflare API keys. So let's see. Yep. It worked. So if we see look what happened here. This one was my playbook provision DUCF, so the one that will provision actual machines. So it starts doing the setup, so it gathers few data around the local machine in this case, because it was running on localhost, as you can see here. And then it reads the vault file, where I have the encryption keys, the tokens for DU and CF. And then it ensures that my SSH key is already on DigitalOcean, because I want to provision machines that do not have password login, but directly SSH keys. And then I ask DigitalOcean to create 3 machines for me. And it worked, evidently. And then I create the domains on Cloudflare about those. Those are basically, I want to have db01.file.bits, ws01.file.bits, and so forth. And then I point app.file.bits to the 2 front ends. And then here I do a little bit of cheating, which is I put the host resolution also on my PC, because otherwise I should wait a few minutes for the DNS to actually propagate. So if we look, let's pick this one. So if I refresh the page, we will see that the 5 totally new DNS appeared here. So that was part of what we did. And here, the 3 new machines should appear as well. Yes, here they are. So we have provision effectively an infrastructure, which is not huge, but still. And we can now go forward with the following step. So the following step will be the first run. What we are doing here is mainly connect to all machines, ensure that the user Ansible exists, and then make the user Ansible actually accept our SSH key, and then put Ansible as sudoer. This because obviously if we are going to use the user Ansible to install stuff, we kind of need it. So the following step will be about actually creating the whole infrastructure. Before doing it, I would like to, well, let's kick it and then we see it. So what it will start to do, let's see the file, it's include two playbooks. This include playbook A and B will actually perform the first one and then the second one, as you can expect. So if we pick the first one and look at it, we'll see that for the host web, we are going to connect to it with the user Ansible and then apply the roles commons and web. While the other one, the DB, that was actually the second line of the previous file, it's pretty much the same, but it connects to the host DB and applies the roles common and DB. So what are those roles? If we go in the roles folder, as we have seen before, we have the common, DB, and web. If we start from common, tasks is the subfolder that contains actually the tasks files. And the first one is, ensure that NTP is present and then configured with a template. And then NTP is running. So let's look a little bit about that template, which I think, if I remember correctly, that is not actually a template. Yeah, it's not really a template because I don't have any variables into it, but I could make some variables into it if it would make sense. Mine is on the web, and it has unlimited access to the web, so it does not really make any sense to me, but it could help some people to have local NTP, and maybe you have two different data centers which have different NTP servers, one per data center. So you want to have a parameter there. You don't want to hardcode and have two different modules there. And as you can see, the code is pretty straightforward. And yeah, I mean, here we end after configuring NTP, we install firewall if it's not yet installed, and we ensure that it's running, which means that we enable it as systemctl enabled firewall D, and we start it. So systemctl start firewall D, and it's all done in here. And then we ensure that SSH can actually pass through the firewall. That rule should be there by default, but it's better to ensure that everything that you need to be there is actually there. So here it ended. It has already provisioned all the hosts as well. So we have seen the common one, which was the first part, and then we have the web part and the DB part. I'm not going to look in that files, but those files are actually on GitHub, so you can go and inspect them as much as you want. So basically, now we have provisioned a database and two web servers. So how can we check if everything works? Well, with Seoul, obviously. If we do a Seoul app.file.bits, actually one of the two web servers just replied to us, and this one is WS02. If we ask again, oh, same one. Okay, WS0 one also replied. And as you can see, this one is a list of databases I have in the newly created database. And, they are the same. They are speaking with the same backend database. That's pretty much what you can use as, a general recipe for the majority of websites out there, with HA kind of, because the DB is not HA, but. So I would like now to tear down the whole infrastructure, which is pretty straightforward. I have a destroy script, and I just run it, and it will destroy everything for me. Now, as you can see, I copy and paste things from the README file. The reason for that is, first of all, because I know that I will surely put some typos in it and then try to fix them. But second, because the first and the last line were pretty long, if you have noticed. The provisioning one and the tear down one. That's because due to the fact that we are using Ansible Vault, which is encrypted, and by encrypted, I mean that the Vault file is this. It's AES 256 encrypted, but since AES is symmetric encryption, you need actually a key. So in Ansible, we can specify a file that contains that key, so that everything is keyed and everything is safe. So if now we rerun the CUs after the tear down, obviously it will fail, probably in a little bit of time for a timeout, but it will fail. And if we look at here and update the page, we'll see that all machines that we provision actually disappeared, and in the configuration, Cloudflare thing, also everything we created disappeared. So as you can see, we have created an environment, managed it, and destroyed it in very few minutes. So going back to the presentation, if I can find it. Okay, so some resources. The first one is this, oops, sorry, wrong link. But it's the slide. I think this one should actually work, even if the date is wrong. And then there is the demo code, the one I showed. The whole Ansible thing is there. Probably you will need to actually put your own keys there for DigitalOcean and Cloudflare. And official documentation of Ansible, that's very useful. It's very complete. It's not perfect, but it's very complete. Some videos about Ansible and things you can do. Some white papers about Ansible and ebooks as well. So just last thing before going to the question part. If you are going to go and grab the source, what you will notice is that actually there are two Vault files. One is vault.yaml, which is encrypted, and the other one is vault.yaml.example. And in the vault.yaml.example, there is actually the example of what your vault.yaml should look like before encrypting it. So thank you. And if there are any questions, yes?
I have one question. How does it work in the backend when you're running an Ansible playbook? Because, for example, before you had the playbook that was ensuring that playability was enabled, that was started, and after that, the port for SSH will be open.
Yes.
So actually, the playbook is wrapped and sent to the let's see, Or those actions are run one after the other?
Okay, so the question is, how does Ansible work in the backend? Since, as we have seen, we enable firewall-D and then we open the port. So the answer is Ansible runs one action per time. The reason why that actually works is the fact that firewall-D does not cut the connections that, when it starts, does not cut the connections that were already live. So Ansible is using the same connection, and therefore there is already the SSH connection there, and so that connection actually does not get dropped. Yes?
So you mentioned that realize Python. It's all Python 2 as far as I know. Are there any plans for Python 3? Because, for example, managing a federal realize system right now means that it pulls a lot of dependencies because Python 2 is no longer there.
Yep.
In the middle of the flow.
So the question is, Ansible is Python 2 mainly. So are there any plans for Python 3 since Python 2 is going away? I would say hopefully soon. But yes, there are plans. And I think that I have seen a mail in the mailing list a couple of days ago where there was Tosho saying that all the main modules are actually working on Python 3 as well. Python 3 is not yet supported for the whole infrastructure and everything, mainly because we are supporting very old version of Ansible, of Python 2, and very old version of Python 2 and Python 3 do not really work very well together. But yes, it's expected to arrive soon. I don't know when, even because I'm not actually on the development side of it. I'm more on the usage side of Ansible.
So will it be like configuration? I want my modules to run Python 3 for
There is actually a module, which is virtual environments, VM, that already manages different version of Pythons. And so I guess it will be implemented in a similar way. That's my guess. Yes?
You said something about the first disadvantage of the position or more like
Sorry, I have not heard you.
there's a disadvantage you pointed out in your slides.
Yep.
Could you shed more light on that first disadvantage about tools?
Sorry, about the speed of agent.
In your disadvantage,
In my disadvantage slide, let's see. So this slide or the Ansible one? The Ansible one? Okay. Okay, so the question is?
could you shed more light on that?
What do you mean?
Yeah, what it means.
Okay, so the question is, what does not very good introspection tools means? Basically, when you get an error, you get something like, you know, in that line there has been an error, kind of thing. And then if you go on -vvv, which is see all the logs that comes from SSH, you arrive to the opposite, where you see every single problem of SSH and basically too much information there, not enough there. So it's like an effort trying to gap that bridge and try to have some useful errors without too much SSH stuff into it.
How about the quick fix? -PVP when failed. So this will
Yeah. Yeah.
question that I've asked is some of the modules have dependencies like, for example, Ansible is set or interest. Those are ideally installed globally by APP or whatever it is. Is there a force to, is there a way to force, for example, to use
So the question is, some modules actually require some libraries to be present, Python libraries to be present. How can those libraries can be managed if not installed globally? So basically, I think it depends is the answer. I would say generally you can use Ansible to install the modules, the libraries that you will need. So you can target only the hosts that are going to actually perform that action. At the moment, the Fedora installer, for instance, of Ansible, actually does not require any of those libraries. So if you install Ansible, I would say on the target, yeah. I mean, you can write them in the playbook. You can actually, the step before using that modules, you can put yum and then name whatever library stay present, and that works. And for instance, there was before the question about Python 2 and Fedora, there is actually a piece of code that you can run in raw mode from Ansible to actually install Python 2 on Fedora hosts, even before trying to reach Python and that kind of thing. So last question. So the question is, a few years back, Red Hat bought Ansible. And when that happened, it was announced that Ansible Core and Ansible Tower, which is the web interface, would be open source. Are there any news? So no, I don't have any news. I am not in a place where I can have that kind of news. But Ansible Core actually was open source even before the Red Hat acquisition, and is still open source. And Ansible Tower, I don't know. I mean, it will arrive. I'm sure about that. And also, there was Ansible Galaxy that was owned by Ansible before joining Red Hat, was closed source, and it was open source a couple of months ago. So, thank you.
Advantage of agentless system is that you do not place your master to the least secure.
Yeah.
But on the other hand, you have to, in Ansible, you have to have all your hosts reachable from the master.
Yeah, exactly. So what you usually do is put, if you have like a three-layer, three-segment kind of design of your network, where one is public, one is like the MZ kind of thing, and one is private, you usually put your Ansible one in the private one. So that from private to private is fine, from private to the MZ is fine, from private to public is fine. So everything kind of works. While if you do it with Puppet, you have to put it in the public one. Because otherwise, the machine on the public segment cannot access your Puppet master if it's in the private network. I mean, you could put it in the DMZ if you want, but even there, you still are opening a firewall hole between your public and your DMZ, which is probably not nice.
Yeah, it's not nice, but that's the case. But you are provisioning you are configuring your services, which are usually like publicly accessible.
Yep.
So you don't want to have. Okay, but you can still have SSH only for.
Yeah.
Okay, it's solvable in the network layer.
Yeah.